Hi there. Today we're going to look at finding an area between the x-axis and the graph itself.
Okay, so here's our function, x to the third minus 4x squared plus x plus 6. And we're looking for the area between this function and the x-axis.
So that means this area here, that's in red,
And
this area down here, that is in green. So in order to find ourselves an equation of some kind that's going to work, we need to come along and find these points of intersection. This value, and this value. And we have our calculator available to us, so let's use it to help us out. So we're going to trace or find the value when x equals, I think it's -1. That's the easiest way.
Boy, that was lucky.
Yeah, it's
You're
the
lucky.
easiest way to do is just, if you think you know what it is, just guess with your calculator and you will oftentimes be right. I think the next one's 2. Yes, y is 0, and I think the last one is 3.
I think maybe you know this problem, Mr. Robs.
Maybe I've done it before. But again, I do that technique sometimes. If I think it's going to be that, I often guess.
Yeah, I think it's easier than having to go through the x-intercept and try to do left bound, right bound, all that stuff. You know, if you see it and you think you know it, then try it.
Okay, so now we have to set up an equation to do this. Well, I know that the integral is equal to the area. And if I go from -1 to 2, that's going to get me the red area. So I'm going to go of x cubed minus 4x squared plus x plus 6 dx.
Well, how do we account for that green area? Because if we take the integral of it, it's going to give us a negative area.
That's a good question. What we can do to account for the green area is we know it's negative. So if I make it negative...
Oh, because 2 negatives will make a...
positive, and it'll be, in essence, adding the area. I'm going to take this from 2 to 3 of the same function.
Okay, and this could get really sloppy, not speaking from experience, but so to actually calculate this all out.
Right.
So we'll let the calculator do some work for us.
Right, and this is saying you have just set up the integral equation. That's done. B part is find the area. I'm not going to do all the calculation. I'm going to use my calculator. Because I know it's also negative here, I'm going to tell my calculator about the absolute value of it. So I can.
Well, but since we're subtracting.
When I take the absolute value, though, then it brings it to the top. I'm going to put this all in as 1. I'm going to go from -1 to 3. Even though I'm saying this is my equation, I'm going to do the
I see what you're saying.
I'm going to do the absolute value scenario.
Okay, so we're not actually using the integral that we wrote to find the area. We're just going to do the shortcut.
Right. We're going to outthink the question. We're going to say we're just looking for the answer. So if I graph the absolute value version, I get this.
There we go. And now we can see everything is going to be positive.
Right. And if I take from number 7, I'm going to go from -1 to 3. And when I do that, I end up with a value that is equal to 11.833.
Or 11.83 repeating.
All right. So that is going to be, let's see.
71 over 6.
All right. Miss Flynn just knows that off the top of her head.
Yeah, that's one of the fractions I've memorized.
Right. She's good. Key to this one, make sure you subtract the bottom area so that you are actually adding them together.
Okay.